is 4809.7 meters. All right, focus. Wow, this thing's not focusing at all. All right, so from there, we're looking at drawing angles in standard position and finding the exact values. So find the cosine value of an angle drawn on the terminal side connecting to -3, -4. So I'm just going to do that on this little diagram. -3, -4 is over here in quadrant 2. So we know that's our angle, right? Then, and this is -3, -4. Then, of course, when we label our triangle, we know that's -3. Oops! I made a boo-boo. -3, -4 is not there. -3, +4 is there. So I'm going to have to change it up. I'm going to have to draw it better, more accurately, down here. Right, so this is where -3, -4 is. Right, but here's the easy part. That's our right angle. That's our -3. That's our -4. And hopefully you recognize this Pythagorean theorem will prove it that it is a 3, 4, 5 triangle. So that now, when we go to find the cosine ratio of this angle, which is our theta prime, it's adjacent over hypotenuse. So it's just going to be -3/5. Hopefully that's in the frame. All right, awesome. All right, zoom back out. That's killing me. All right, the back page. So this first problem, let me angle this down just a bit. Too jittery. Doing the robot. Okay. The point 5, -12 lies on the terminal side. Find sine, cosine, and tan. Then find the length of the terminal side of the angle. So that's kind of weird. 5, -12 is, of course, in quadrant 4. Did I get that right this time? Yeah. 5, -12. All right, so that's here. Let's go ahead and make sure we know that theta is this. And that this will be our theta prime. And we can label our 5 and our -12. And for good measure, we should probably go ahead and find the hypotenuse using Pythagorean theorem, right? 5 squared plus -12 squared equals h squared. So h is going to be 13. All right, so that's our 13. H equals 13. Okay, so what do we know? We know that the sine of theta, the opposite of our hypotenuse, is going to be -12/13. The cosine of theta, 5/13. And the tan of theta, -12/5. All right, zoom in, focus on that. Make sure, yeah, that's better. All right, the last part asks find the length of the terminal side. Well, that's just the length of this arrow. It's 13. Okay. Next question. The point xy. xy, where's that? Lies on the terminal side of angle theta. Draw the terminal side. The length of the terminal side has a value of r. Draw the angle as if located in quadrant 2. So let's do that. All right, let's call that. And the length is r. And it has the coordinates x, y. Right, so this is theta. So this will be our theta prime. Find tan theta. Well, there's not a whole lot here. All we have is y and x. Opposite over adjacent. Yep. Determine an expression for the value of x in terms of r and theta. All right, so here's what we know. That how do we connect theta with r and x? Adjacent and hypotenuse, that's going to be cosine. So we know that cosine theta will equal x over r. Therefore, x is equivalent to r times cosine theta. And likewise, if we were to write sine theta is equal to y over r, then that's going to mean that y equals r sine theta. All right, any of you took vectors in physics? No. Those are actually our horizontal and vertical components of the vector that we could call r. But another class, another time. I really hate we can't do more of that. All right, and the last one. Cosine theta equals 7/25, and tan theta is less than 0. So, draw the angle in standard position. If the cosine is positive and the tan is negative, it has to be in quadrant 4. Okay, 7/25. All right, so probably not to scale. So the cosine, that's the x, the adjacent over the hypotenuse. Right? Missing side here, so we got it drawn. We have our little arrow, right? That's theta. Remember, this will be theta prime. Okay, so 7 and 25, using Pythagorean theorem, we're going to get that this is equal to 24. Okay, find the sine of theta. So sine of theta is going to equal opposite over hypotenuse. 24 over 25. Find theta prime, the reference angle. So for that, right, we're going to have the sine of theta equaled, what, 24 over 25. So the theta will equal the inverse sine of 24 over 25. Or, as we know, 73.7 degrees. So we'll go ahead and fill that in as 73.7 degrees. Okay. Therefore, find the measure of theta. Well, theta is this amount. If we know this remaining piece here is 73.7, that is the piece of the puzzle that will make the entire circle. So we're going to take 360 and subtract theta prime. So 360 minus 73.7. What is that going to give us? 286.3? Is that right? Yeah, that's right. Now, does that make sense? 286 degrees? Of course, because it goes just past the 270. Determine the coordinates of a point at the end of the terminal side if the length of the terminal side is 100. So all we've got to do here is think about this as, how do I get that to 100? Times 4, times 4, times 4. Right, trig is very well connected to similar triangles, so we're really just thinking about dilating this triangle by a factor of 4. Right, remember the 7, the 24, and 25 are just ratio values. So all we've got to do is figure out what the new coordinates would be. 28, and that's going to be 96. So the x is 28, the y is negative 96. Has to be negative because it is indeed down. Make sure I fix that on the others. Yeah, all right. Anyways, you guys won't forget that. Right, positive, down, negative. All right.